Okay, I've been wanting to do this for months and decided that I'm just going to sit down and do it. I want to talk about how AI is too expensive for software engineering. And the summary that I have is I want to talk about the subsidies for the models and for the tokens, how we're running into diminishing returns on running these models, the predictions that I have for the future on what will be good, what will be bad for these models, and then some rounding up with conclusions. So let's talk about subsidies. So models today, the frontier models are highly subsidized, very highly subsidized, and even from Anthropic themselves have admitted that when they sell a $200 subscription, they're giving you $5,000 in compute. Now, people have talked about whether this is just a marketing blurb or not, but regardless, this is an admission that there are subsidies. And if you look at the prices that they have for things and the losses, if you look at the revenue versus the losses that OpenAI and Anthropic have, you find that from previous years, they would have to charge at least 10x to break even. And so with these new models that have been introduced just in the past 6 months or so, these models are much more expensive. And so it could easily be like a 25x to make up for these new models. So AI companies, in addition to all of this, have been running losses for 5 years plus, and they need to make that money back. They have to be able to pay the salaries. They have to be able to pay back their venture capital, and they also need to make enough money to buy new capital, new equipment. They have to replace old GPUs, hard drives, RAM, and as new GPUs come out that are more capable, they're going to have to buy those. And as demand for AI rises, they'll have to build even more data centers, which means they need to make profit in order to be able to grow. So the thing is that we've been running into what's called diminishing returns. Now, diminishing returns means that as you put more inputs into something, it doesn't go up forever, right? You actually reach a point of diminishing returns and then potentially negative returns. And so this illustration gives a good picture of this. So when you first start out with a lot of these things, it looks like you have, hey, we're growing exponentially here. It's going to be awesome. And this was, the first 2-3 years of AI. As we started with models that were only millions of parameters, and as we moved up to tens of millions and hundreds of millions of parameters and up into billions of parameters, it says, hey, we're just having kind of, there's linear relationship, and we're just exponentially growing. We're giving more data and more computation into this. We're giving exponentially more into this, and we're just going to go up forever. And so people just assumed that everything will just go up forever. And if you extrapolate this exponential growth here, you would just see that it just goes off the scale. Like that's what we predict. However, in the past year and a half or 2 years, these companies have started to realize that they're in this diminishing returns category. So they're putting more data, they're creating bigger models, but those models aren't giving the output that they thought it would, right? They're actually, the bigger they make the models, they do get better, but they're getting better at a slower rate, right? And there's potential, we haven't seen this, and I don't know if this is going to happen, that if we make models too big, that will actually get negative returns. And that actually seems reasonable, because if you make a model too big, that means that it would require so many GPUs to run it that no matter what you do, you would have negative value. It would cost you more money than you could ever charge someone to use it. So that's the idea of diminishing returns. So let's talk about the three major components of AI, which are the data, the models, and then the time to run them. And with data, we've essentially already run into diminishing returns within the first, 2-3 years of doing this. Basically, everybody has consumed all of the data that exists on Earth for everything that human beings have ever produced, right? There's still some data out there that they haven't collected, but they've collected most of it. And they're definitely crawling the web for any new data that they can get. However, most of the data has already been consumed. Like, they're not going to triple or quadruple or get 10 times the amount of data that they already have. And another problem is that the data that is being produced now, there's a lot of it that is AI generated. News articles, blog posts, social media posts, reviews for things, videos, audio. A lot of things are being created by AI, and you run into a problem of model collapse, where if you feed AI its own poop, it goes in this cycle and it just gets worse, right? The model collapses under its own weights, essentially, and this is a known problem. And the more AI content that gets produced and thrown out on the internet, the more this becomes a problem, because you can't just scrape the internet anymore for data, because you risk this model collapse. All right. So then, if we can't grow the data, because if you grow the data, you can get better performance. Well, the other thing that we can do is we can grow the models. And so models started out with millions of parameters and then billions. And now the frontier models, the top models by OpenAI and Anthropic, are somewhere around 3 to 5 trillion parameters. Now, they haven't published the exact number of parameters. This is essentially estimates that we have, because these companies aren't actually as open as they all say they are. But 3 trillions of parameters is an enormous number of parameters. That means that to serve one person, they need like a couple dozen GPUs, right, from their data center just to serve one person, right? At least for these top models, right, at top performance. And that's probably why they're cutting back on, like, secretly kind of lowering the performance of some of these things, so that way they can kind of, skimp on some of these things. But it takes enormous amounts of compute to serve a top model at top performance. And the thing is that Anthropic just, was it a month or so ago, showed how they created a C compiler. And that C compiler kind of works. I mean, it's not really, it would not replace GCC or Clang. It doesn't do any, for example, it doesn't do any type checking, and the code that it does produce is some of the slowest code that any C compiler has ever produced in the world. So that means that the best models in the world still cannot replace software engineers. And so what would it mean to be able to replace a software engineer? It means that you don't need a human being to ever look at the code, right? You could ask an AI to produce something for you, and it could do all the design, all the engineering, all the testing, all the QA, and you could trust it. Like, you would never have to look at the code. That's what it means to replace a software engineer. And the models that they have with 3 to 5 trillion parameters are nowhere near that happening. And because of this diminishing returns, we may need 50 trillion parameters. We may need 1,000 trillion parameters, right? We may need a quadrillion parameters in order to have models that are good enough. We don't know. We might know, or we might be able to get an idea of it if these companies published their data and their results, but there's no publishing of this thing. So we don't know where we are along this curve for diminishing returns on model size. But we know that we're somewhere in here. And the further along you are, the worse it gets, right? The more it will take to yield a smaller return. Okay, so those are the models. The other thing that you can do is time. You can use a smaller model and just run it in a loop. And what you can do is take the output from a loop and modify the context window and say, hey, look at, run the tests, look at the requirements, and compare your output here to those. And if there's anything that you can improve, please run again. And so you can have this thing, and they call it thinking, or, different companies have different marketing terms for this, but it's essentially just running the model in a loop to slowly get better results. Now, the thing is, when you run the loop the first time, you'll get better results by a decent margin, but you run into the same problem here, right? As you run more loops, you actually get less out of it, right? Because you'll run into some kind of local optimum. And so that means there's diminishing returns on running these models in loops. That also means that you have to wait. You have to wait while this thing is thinking. And we're already waiting minutes or hours or days for these things to do programming. And so you really don't want to wait longer. And the thing is if you make them wait even longer than we currently are, there's no guarantee that it'll get any better. In fact, Anthropic and OpenAI have tried this, and we've essentially reached the diminishing returns point for time. So this is kind of a problem. We can't really get much better on data. We can make bigger models, but they'll cost even more to run. And we don't really want to wait an infinite amount of time. And even if we could, we're not going to get much better than the current level of thinking that we already have. So before I do predictions, I want to talk about one thing, that there is one other thing that we can do to improve, and that's to have algorithmic improvements. And I think this is essentially the only way forward, but it means having a breakthrough on the level of transformers. And there's no guarantee that you'll find this, and there's no guarantee to the timeline that you will discover this, right? We could discover a new algorithm tomorrow, or we could discover a new algorithm 10 years from now. So you can't base your business on something that hasn't been discovered yet. So these are the things that we can control. So based on that, what do I think, what do I think is going to happen? And I think people and companies will cancel subscriptions once they have to pay its true cost, right? Eventually, the subsidies for all of these models is going to have to be cut, and they're going to have to charge not just break-even prices. They're going to have to charge prices that will make up for the past 5-6 years of running a loss, right? Plus, they're going to have to charge enough money to pay the taxes, and they're going to have to charge enough money to pay back their investors, and they're going to have to charge enough money to actually make money to grow. So that means prices are going to have to be tremendously higher than they currently are. I mean, at the beginning here, we talked about, 10 to 25 times what the current prices are. But the truth is it's probably going to be 30, 40 times what the current prices are. Which is just absolutely enormous. So the second thing is, I think small and focused models will be the ones that make money. So I think these large frontier models, we're going to stop even making them, right? And we're probably going to kind of throw away the ones that we currently have. The ones that we have are already too expensive to be priced in the real market. And so I think models that are in maybe the tens of billions of parameters that are very focused and trained on one specific thing, those are the models that are going to make money. They can actually make profit. It kind of remains to be seen whether that's true, but I think that those maybe models that maybe not much bigger than 70 billion parameters, those are the models that are going to be, that you're going to be able to make money on. Now, the problem is 70 billion parameter models and smaller can be run locally. So these companies still have to make back, like I said, the 5-6 years of losses. So which is going to be cheaper, running it locally or buying it from, these large companies? It's going to be cheaper to run it locally, probably, if you're going to use it a lot. And so what's going to happen is I think these companies are going to be in, big financial trouble. All right. So those are the major things I think is going to happen. So my major conclusions for this is don't try to use AI to be an integral part of your business, right? Don't make it part of your workflow, because as soon as the price goes up, you're going to be screwed over, right? Use it right now. Right now, you've got good prices. It's subsidized. Use it for learning. Use it to increase your own skills, right? Use it, ask it questions to figure out things, and use it as like a better Stack Overflow or something. That is what you should use it for. Don't let, the second point, don't let AI dull your skills, right? We already have a couple of surveys and studies on this, where if people use it to just do the work for them, their brain already starts to decay as far as skills are concerned. And so don't let yourself get lazy. Use it as like a reference book, right? And the final point is brace for increasing prices, right? Prices are just going to go up, and it's going to be crazy. Like the prices are just going to be crazy. I don't know when this will be, but probably within the next year, maybe by the end of next March, it's going to be obvious that the prices that we currently have are just, you're not going to have them. Like the prices are just going to keep going up, and these companies are going to have to recoup their costs. So that's about it. I have some more things to say, but that's good enough for today. And all right, have a great day until next time.